So today we are going to be looking at, we have been doing beams since last week. So now we are going to be shifting forward to a new section here, which is the centroid of lamina. Centroid of a lamina. This is also a very interesting topic as well. We actually have two sections here, centroid of lamina and center of gravity of solids. The last couple of years, I've been seeing more questions on centroid of lamina. But the centroid of lamina, this is where you'll be asked to determine, you can see there are some shapes here. There is a square here and there is a rectangle here. And you can see there's a little dot here. That is actually the centroid of that. That's the centroid of that element. Now with lamina and solids, lamina has a zero thickness. So the volume and the mass is not really taken into consideration when we are calculating the centroid. So with a solid, that is where we have CG, which is the center of gravity. So in this case, of course, you understand what I've just drawn now. So there is a point here where you will be asked to determine the centroid, the X and Y coordinate, the center of that particular. We have different shapes. So I want you guys to see here. This one is for square. This one is for rectangle. This one is for a disc. And this one is for a semicircle. So for a semicircle, this point here is the X and the Y bar. And how do you determine that? So with the X is 0. These are standard formula. And then with the Y, so the distance from the X axis to that point there of Y is 0. And then with the X is taken as 4R over 3 pi. So there is a way that we measure the distance from the axis. This is the Y axis, and then we have the X axis. So questions are always coming out from this aspect. Trust me. So we are going to be dealing with some serious calculations here. But I want you to master this and this one as well with right angle triangle. The Y coordinate is 1/3 of the height, and then with the X coordinate is 1/3 of the what? Of the width. This is the distance is B here, and then this is the height. So these are the things that we are going to be using when we are doing our calculations. Now, this is the area where I'm going. Now, so how do you determine the centroid? So you can see the centroid, which is the point in the middle there. I'm going to remove this axis of rotation. Let me remove that. I'm still going to put it back. Now, the centroid is the center. So we have the X, call it X bar and the Y bar. So the X is measured from the Y axis. This is Y axis and this is X axis. So we have a square there. So this is the distance from the what? From the Y axis to the center, and then this is the distance from the X axis to that center there. So that is how we determine the centroid. Now there is a formula that we normally use to determine the centroid. There are some calculations that we need to do. So I'm going to use this as an example. Now, in order for you to get your X bar, which is your X coordinate, now there is something called moment of area. Moment of area. So the moment of area is the product of the area multiplied by the distance from the axis of rotation. I'm going to put the axis of rotation now. Now, I have two axes of rotation there. So this is the Y axis of rotation, and then this is the X axis of rotation. So if I want to calculate the moment of area of ODBC. ODBC. So it's going to be equals to moment of area. This is the axis of rotation here. So I want to calculate this distance. So it simply means that this laminar ODBC is rotating about the y-axis. You can see the rotation symbol there. So it's going to be equals to the area of that particular lamina multiplied by the distance from the axis of rotation. So the distance from the axis of rotation is from this point to this point because it's rotating about the y-axis. So we have this formula here. The moment of area about y axis of rotation is the area multiplied by the distance from the y-axis to the axis of rotation, which is the x bar. The same thing applies to if you want to determine the moment of area about the x, if this is the axis of rotation. So it simply means that it's rotating the other way. So it simply means that you are going to multiply the area of that lamina by the distance between the axis of rotation and the x-axis, which is y bar. I don't know if you can just picture this. So those are the axis of rotation. So it simply means that when the formula is like this, you can now transform the formula to your x bar, which is going to be equals to the moment of area about the y-axis divided by the total area. The total area is still the area because it's a square. So you can see there is a formula here. The moment of area about y-axis is you can see they wrote a1 x1 plus a2 x2 plus a3 x3 divided by the total area. The same thing applies for this one as well. The one for this particular coordinate as well. X bar, y bar. So we're going to see how this is being actually applied so that you will actually get a true picture of what we are saying here. Now, if you look at this activity here, this is how they will ask the question. Now they will say calculate the coordinates of the centroid. Coordinate of the centroid is the x bar and the y bar. Same thing with this question as well. Calculate the coordinate of the centroid. If you check that question activity 4.3, you can see this is question 1. Calculate the coordinate of the centroid for this one, question 3. So this is how they will ask the question. So how will you go about doing this? So the first thing you have to do here is, now if you look at this diagram, you can actually divide this diagram into two. You close it at this end here so that you can choose either of the parts as part. What is my part 1 and this is my part 2. So I have I have two rectangles there. So how do I determine my coordinate? So there is a table that you have to draw here. You can decide not to draw the table. So with the table, you label it as parts because now it has been divided into two. Area is in millimeters, so you write millimeters squared, and then this one will be the coordinates. Coordinates, which is your x and y. The coordinate of that part. I will show you how to do that. So if you look at this diagram here, we have two parts. We have A, B, C, D, right? A, B, C, D. Then there is another part there which is E, F, G, H. This is the first part. This is the second part. E, F, GH. Now we need to determine the area, because let me just show you the formula. The moment you first determine the moment of area about the y-axis is the total area multiplied by this, which is the axis of rotation, is going to be a1 x1 plus a2 x2. So that for the x coordinate is going to be a1 x1 plus what? A2 x2 divided by the total area, which is a1 plus a2. You're also going to determine the moment of area about x, which is the axis of rotation. So if x is the axis of rotation, the distance is going to be the y. So this is going to be total area multiplied by y bar equals to a1 y1 plus what? A2 y2, because we have two parts. So here you can now determine the y, which is a1 y1 plus a2 y2 divided by what? A total. So the value of your x and your y is going to be the position of the centroid of this particular lamina. So this is the reason why we need the area. So that's the reason why we are determining the area. So the first one is A1, because we made the first one. Of course, the area of a rectangle, of course, is length times breadth. So that's going to be what? 60 times 20. The area there is what? 120 is 1200 millimeters squared. And then what is the x? X and y. We draw. If you don't want to draw, you can just the x coordinate of that section is from the, you measure from the y-axis to the middle, there. That is 60. That should be 30. And then for the y, you are going to measure from, this is the middle, right? For the y, you are going to measure from the ground here, from the x-axis, to get your y1. Okay, so your y1 is going to be what? So you have to be able to determine. So this is 20, right? So half of 20 is what? Is 10. So that will be what? That will be 50. So that is the xy coordinate of this, the first. I'm also going to do the same thing for the second element as well. Also to the middle from the axis. Yes, I'm going to calculate the area. So the area is 15. That will be 15 times 40, right? 15 40 will give me what? I think it's 600 or so. 15 times 4. Yes, 600. So that's 600 millimeters squared. So that is A2. Now the coordinate of that, the x and y coordinate of that is x. X you measure from the origin. From the x you measure from the origin center there. The thickness there is 15, right? So this is going to be what? 7.5. So it's going to be 7.5 plus 22.5. So you can see this 22.5. This is also 22 what? 22.5. So it's going to be 22.5 plus 7.5, 30. So my x is 30 and my y is going to be what? 20. So my y is that distance there to the what? To the middle there. 20. Okay. Don't forget these coordinates. This is your x1, y1. This is your x2. This is your y2. So what you need to do now is to substitute. The rest is easy. You have your a1, x1, a2, x2. You can calculate the total area. You can just the total area there is what? 1,800 millimeters squared. So I'm just going to substitute now. I'll be writing that on the next page. A1 x1 plus A2 x2 divided by what? A total. So let's calculate that. A1 1,200. What is x1? X1 there is what? 30 plus A2. A2 is 600. X2 is what? X2 is 30. The total area is what? 1,800. And someone give me the value of the x centroid of that. And with the y1, the y bar is a1 y1 plus a2 y2 divided by a total. So this is a1 1,200, y1 is 50, a2 is 600, y2 is what? Y2 is 20 divided by the total area, which is 1,800. Can someone give me the value of the first one? 30. So 30 millimeter. The second one, you should get 40. Therefore, the centroid is 30, 40. That's the centroid of that element. That's the answer. This one is actually very easy. In a situation whereby you have a hole inside, you have to subtract the area of that hole from the cardboard. I will show you the second one. Any questions? Let's look at a more difficult one. So you can start doing your calculations by drawing a table, or you can just calculate without using a table. So it depends on you. So the one I'm going to do now, I'm not going to use a table. I'm just going to calculate the centroid, because that's what the question says, the coordinate of the centroid of this lamina. If you look at this lamina, the first thing I want you to observe, just like what I said initially, is remember that this is your y-axis and this is your x-axis. So whatever that you are measuring, whether you are measuring x1 or y1 or x2 or y2 or y3 or y5, it has to be from the axis. You measure from the what? From the origin there. If you look at this question, there are three things that I'm seeing here. I'm seeing a square here. I'm seeing a semicircle here. And I'm seeing a what? A triangle here. So the first thing I'm going to do here is, I'm not going to use table this time. I'm just going to calculate the area first. A1. This one is a square. Of course, the area of a square, of course, this is going to be 100 what? 100 squared. So this will give you 10,000, right? This is 10,000 millimeters squared. A2, A2 is a hole there, but it is a semicircle. And remember, the area of a cylinder is half of pi d square over 4, will give you the area of that hole. Because normally cylinder pi d square over 4. So pi d square over 4, half of it, because it's a semicircle. So you can calculate the area by saying 1 over 2 pi multiplied by the diameter there is what? Is 60. 60 squared over what? Over 4. H1. Then I'm going to calculate my A3 here. The area of the triangle is half what? Is half base times height. So I can use my base distance is 100. So this the distance DC, that is 50 here, 50 here. That gives me 100. Then multiply by my height is what? 90. So I'm going to get my A3, which is a triangle. The second one is what? This area, 1413.72. And then the area of this triangle, this is 9,000 over 2. This is 4,500. You can see that, meter squared. Now, how do you calculate the total area? You are not going to add this time because there is a hole here. That hole, you can see there is a hole there in the portion of that square. So I'm going to show you how to determine the total area now. So you are going to subtract the area of the square from the area of the hole. Then you add it to the area of the triangle. Because it's a hole, there is no material there. That's the first thing you are going to do here. The total area. So I'm going to subtract 10,000 minus the area of the hole 1413 point what? 0.72. Put it inside the bracket. Then I'm now going to add it to the area of that triangle. Can someone give me the total area value here? Thank you. 13086.28. Okay, let's calculate our centroid moment of area about the axis of rotation of X is going to be the total area multiplied by what? The distance from the axis of rotation. Then we have A1, Y1 plus. I want to show you something here. Now, this is actually going to, because our 2 is the whole, so this is going to be minus A2, Y2 plus A3, Y3. Why? Because that second section there is a whole. So when you are taking your moment here, you have to be very careful. So you subtract from the one from the whole. So it has to be minus. If there was another triangle, maybe there was another triangle somewhere here, and then there is no triangle on top, it was going to be minus that of the whole, then minus that of the third one, because it's a hole. It's not, there is no material there. It's a part that has been cut out of the lamina. Okay, so this is what we are using. So we are now going to have the total area. You can substitute right away. 13086 point what? 28. Now we are going to, our A1 is what? 10,000. I want to ask you guys, what's going to be your Y1? Look at the diagram. Let me remove this. The Y1 is going to be measured, of course, that distance to the middle there is going to be what? That is going to be 50. This is your Y1, because your one is, this is the square, right? So the middle is 50. So you multiply that by 50. minus A2. A2 is the area of the hole, 1413.72, multiplied by, can someone tell me what is Y2? Okay, so with Y2 is a semicircle, right? Now let's look at, remember that was something I was showing you for semicircle. Can you see here? 4r over 3 pi. I was showing you something here. So this is the Y value for a semicircle. So it simply means that the distance from that, you can see from that axis to that centroid there is 4 pi over what? 4r over what? 3 pi. So you are going to do this. Um, so with this one here, this is what I'm going to do. 4r over what? 3 pi. So you can see that is the distance. Of course, the center is going to be somewhere around here. You see that formula there. So you measure from the x-axis, that is the middle there. So the distance there is 4r over 3 pi. We are still going to substitute that when we are, then plus A3. The third one is the what? Is a triangle, which is what? 4,500 multiplied by Y3. What is Y3? Your Y3, now for triangle is somewhere around here. Your Y3 is going to be the distance from, you measure from the axis, remember? So this is going to be what? Your Y3. So remember there is something like this. Now, how do you determine that distance? Now we know that AD is what? AD is 100, isn't it? From this point to this point is 100. What is the distance from this point to this point? Let's go to the to what I was showing you. Yeah, you're going to be using, so it's going to be what? You divide by 3. Can you see the distance here? For this one is 1 over 3 of the width. This one is 1 over 3 of the height. So if you go back there, it's going to be what? That's going to be 1 over 3 of 90. That's going to be what? 30. So this distance here is going to be what? 30. 30 plus 100 is what? Is 130. So you now come here, you multiply, your Y3 is what? 130. So this one, I'm just going to substitute 130.86.28 y bar equals to 10,000 multiplied by 50 minus 1413.72 multiplied by what's the radius there? The diameter is what? 60. The radius is what? 30 divided by what? 3 pi. Then plus 4,500 multiplied by 130. So guys, I need calculator here. You can first simplify this one. You punch this one carefully in the calculator, taking note of these brackets. I'm going to put them inside the green bracket. You can see you multiply first before you subtract or you add. Because sometimes students just punch everything at the same time, then you get the wrong answer. So you first group them, put them inside the bracket. You have your A1, Y1, A2, Y2, A3, and Y3. Yes. So when you get whatever you want to get on the right hand side, so you now divide both sides by 13086.28. Remember, this is what we want to get. So whatever you get here, you divide it by 13086.28 for us to get the y coordinate of the centroid. So this is where students normally get it wrong. At this point where you have to punch everything in the calculator, but I would advise you to first simplify them, multiply this one, multiply this one, multiply this one, then whatever you get, then you subtract and then you add, so that you will not get any wrong answer. Carefully. 12.73. Jonathan, which one is that? Is it the total on the right hand side? Guys, you know what? Just give me, because there is no space, just give me the value of the y bar straight. You can simplify them in your notebook and give me the value. 81.54. For the one of x, we don't need to calculate the x. Do you know why? If you look at this diagram, you can see that there is a line that passed through the middle of all the area. The triangle, the square, and the what? So the x you just measure is going to be what? The x is what? No. What is the x? The x is 50. C is here. You just measure from here, to the middle. I thought you said 25. Okay, 50. Okay, sorry. That's 50. Because of that line there, that line from E that passes through the triangle, the square, and the semicircle. So that distance there is, you don't need to do any calculation there. Your x there is what? Is 50 millimeters. Yes, yes, of course, of course. If you actually calculate, you can try it. If you actually calculate x by following this formula, you will get 50. You will get 50. Moment of area about y. If you use this a1 x1 plus minus a2 x2 plus a3 x3, you will get 50. You can try it. This is the coordinate of the centroid. Guys, I want you to try question 3. Before you start question 3, I want to show you that there is something here. There's a right angle triangle here. First, get your A1, get your A2, get your A3, and then you can start with your calculations. If you want us to do it together, we can do it together. Should we do it together? Okay. I'm not going to use table here. Okay. If you look at this lamina here, I have a hole there. There is a hole here. You can see that hole of 40 by 40. That's a square. I'm going to take the whole area as my 1, and then 2 as my whole, and then I'm going to take this outside here, which is 3, as a third area. Area 1, A, B, C, D, E, F. Let's just put this one E, F, right? So that is 150 times 160, isn't it? Let me label it A, B, C, F. 160 times what? 150. You said is what? A2, that's the area of the hole. That is 40 squared, which is what? There is another area there, A3. Area of a triangle is half base, which is 60, times height, which is 60. This will give you what? 1,800. So now let's calculate not yet. Not yet. When you want to calculate your total area, see what I'm going to do here. Your total area now, that is when you subtract areas. The total area is going to be equals to 24,000, right? minus minus. You do that here. You can also do that as well. You still get the same answer, but you can also do it in this while you are calculating the total area. Okay, now we have the total area, and then we have our A1, A2, A3. So now we need to calculate exactly correct. So let's start with moment of area about Y. So this is going to be A total multiplied by what? X bar equals to A1 X1. Need to be careful here. Minus, I told you the reason why it's minus. Another minus again, A2, A3 X3. When you are dealing with calculation of centroid of lamina, you need to be very careful. This is where the student normally make mistake. They write plus plus here or plus minus here. Remember the previous one we did, it was minus then plus because there was a hole there, the semicircle. But this one you can see we have a square hole and then we have a right angle triangle just at the top right hand corner there. So that's the reason why we are subtracting. So let's substitute. The total area is 20600 x bar. A1 is 24,000. What's going to be our x1? X1 is just 80. Remember, this they didn't put it, but this is y and this is what? X. So from it's just the middle. You measure to the what? To the middle, the center is 80. That's 160. Half of 160 is 80. Then minus A2. Here we don't need to rush. We need to be careful. That's 16 what? 1600 multiplied by. Now, the distance. Can someone tell me the distance from here to the center of this hole? That is your x2. Anyone? Now, the total length there is 160, right? So I'm going to subtract 160 from this distance. What is that distance? They said this is 15, right? Thank you. That is 35 because this is 40. So this is going to be what? 35 millimeters. 160 minus 35 is what? 125. Minus our A3 is 1800. Of course, that one is easy. That is, remember, is 1/3 of the height and the 1/3 of the, so that's going to be 20 because that is 60. Can you see? 1/3 of the height, 1/3 of the width. So just is 1/3, 1/3. So 1/3 of 60 is what? 20. I want you guys to just give me the value of this X bar. Because of space, 81.75. They've given me the answer here. 81.75. Don't forget to put the unit millimeters. Let's calculate for the y coordinate. I'm going to do the same. Okay, let me just crop this because I already put the dimensions here. Let me just do this. Here we did moment of area about at the axis of rotation we took y. Let's do the one about the axis of rotation which is x. Okay, so it's going to be A total multiplied by Y bar equals to A1 Y1 minus A2 Y2 minus what? A3 Y3. So the total area is, I think it's 20600, right? 206, right? 206, yes, 20600 multiplied by Y bar. Our A1 is 24,000, right? Now, what is our Y1? Y1, you just measure from here to the center here. It's 75. 75 minus, I'm going to be very slow there. A2 is what? 1600. 1600. Y2 is what? 35. Good. Minus my A3 is 1800 multiplied by Y3. You are measuring from this point to this point. Now, we can get this point here, which is what? 20. Now, remember we are measuring from down. So now what is the distance from this point to this point, from E to A? What's the distance? It's 150 minus 60. 150 minus 60 is going to give you this distance, isn't it? 150 minus 60. It will give you this space, isn't it? That's what? 90. 90 plus that 20. Distance from here to here is what? 20. Don't forget that you have to measure from the axis to the center, to the middle, both on Y and on X. So it's going to be 90 plus 20. It's going to be what? Y bar will be what? 35,05, right? That is a coordinate of the centroid of that whole laminar section. I think we made a mistake somewhere here. This 20 is actually this distance, because the triangle is upside down. Okay, okay, yes, that's correct. That's correct. Maybe I didn't hear correctly. So that's going to be 130. You know, sometimes this thing is the way you view it. But that's a smarter way of, that one is even quicker. Because I actually wanted to find that distance, then you now subtract from 150. So the answer is going to change. It's going to give us what? 73,30 millimeter. 73,30. So these are our what? These the coordinates of that section. Let's check whether what we got is correct. Question 3. Let me check. Question 3, 4.3, 81.748, 73.30 is correct. It's correct. You can check the new textbook because I'm using the old textbook, but I suppose the answers should be the same. So this is how it is done. This is how it is done. Any questions? Let's go deeper into the more technical one. Is it the same diagram here? 40, 120, because I took this from the new one. 100. Yes, I think it's the same. Can you guys try this question 4? I'm sure you should be confident enough now to. Guys, I want you to look at this section here. I don't think they wanted to write. It's not a square. It's actually a right angle triangle. There is a hole here. Yes, it's not a rectangle. They just put that dotted line just to indicate the dimensions. Try question 4 and question 7. With 4 and 7, then we'll be done with lamina. Then the center of gravity of solid. Questions are not coming out from this aspect, but I'm still going to at least do maybe like 2 questions from that part. Then we'll be done with the statics. Just going to be looking at 2 questions. I'm just going to be showing you the concept. It's similar to that of lamina. It's very, very similar. The same, but just that in this case, you are going to be using volume instead of area, because this is a solid now. It has a volume and then it has a thickness. It has a mass. We're just going to be looking at just 2 questions there. Then we'll be done. We'll be done with lamina. Bye, guys. See you guys tomorrow.